Okay, this first video on rate of change is going to talk about how to find the rate of change of a line. To find the rate of change, or as we said, slope, those two words go together. If you're looking for the rate of change or slope of a line, apply that phrase rise over run directly. The first objective in doing this is in finding two good points that can be used to count. Consider the following graph and look carefully with me as we go. Good points are points that cross at these little perfect edges of the square. So what we're going to do here is kind of look at this and identify as many good points as we can, because that's what you kind of have to do whenever you work through these. This is definitely going through the square part of it, through the line. But as you look, that is not crossing at a square. This is not crossing at a square. This is not crossing at a square. This one is. This is not. This is not. This is not. That one is. No, no, no. Yes. No, no, no. Yes. No, no, no. And then there's no more there. But you notice that each of our points has the same general amount in between each one, because if it's a line, then the rate of change of those points is going to be pretty identical along the way, because it's consistent. So keep in mind, sometimes points are actually on the problem, similar to the graph we have right here, which is one where they give you the problem and they actually give you 2 points. Alright, so in either case, once those points have been identified, your next necessary skill is counting. So what you will think is, what do you mean counting? That's easy. Yes, it is. That is why people who mess up on slope or rate of change of a line, it's simply because they didn't practice it, they didn't take it seriously enough, or they just don't care. There are a couple of ways to implement the counting skill. No matter which method you use, always start from the point on the left. So if we were given these 4 questions here, following, counting like a board game. Again, identify 2 points. Your first point is typically, unless the problem is just difficult, is typically on the y-axis here. So notice that that crosses right through like it's supposed to. And then from there I usually scan to the right. No, no, no. Yes, that is one right there. And from there what we do is, again, we start from the leftmost point and we count our rise, which means are we going up or down to get to the other point, and we count our run, which means, again, always going to the right. And so counting like a board game, I go up 1 and then 1, 2, 3, 4. Again, you count like a board game, up 1, over 1, 2, 3, 4. Do not go 1, 1, 2, 3, 4, because that's not how you would count in a board game. If you were counting squares or counting hops, it would be 1 hop here, and then 1, 2, 3, 4 hops that way, which is your run. Again, your rise was 1, which is why it's positive. Your run was 1, 2, 3, 4, and so the rate of change of that line is 1/4. Your rise was 1, your run was 4. That is all you have to do. It is a counting exercise. Again, people who have issues with rate of change, it's because they really either they just don't want to know, or they don't ask enough, or they don't practice enough. It's really not hard to do, which is why your teachers typically do not have sympathy for you if you don't know how to find the rate of change of a line. Again, looking at the second one, y-axis crosses here. Looking for another good point, looks like there's one here. Sometimes they're really close. Here your rise is to get, again, from the left point to the right point. Always start from the left point. Your rise in this case is 1 jump, and that is a -1 because we went down. Your run in this case is 1, 2, which just makes your slope -1/2. Again, you go down 1, then over 1, 2. Down 1, over 1, 2. Not 1, 1, 2, 3. It's down 1, and then from there, 1, 2 steps over. Alright? Do not count the same thing twice. Just like if you were playing Monopoly and you counted a 3 and you were on this spot, you wouldn't go 1, 2, 3. You'd go 1, 2, 3, because you're already standing there. So again, whenever you're counting, that counts as 1. Now we're starting from there, 1, 2, to get to the other spot. Again, going up is positive, going down is negative. Looking at this one here, again, it's nice enough that it crosses at a nice spot on the y-axis. Now we glance, nope, nope. Looks like a yes here. In this case, again, starting from the point on the left, and you always want to start on the point on the left because we want to go right. Here I count 1, 2, 3 hops down, which is a -3. I count 1 hop over, which anything divided by 1 is itself, it means that your rate of change of that line is -3. Again, from here I went down 1, 2, 3, and from there over 1. Remember, again, you do not count the starting place when you change directions. You simply start counting in the other direction. So 1, 2, 3 down, 1 over is -3 over 1, which makes your slope -3. Here, again, it crosses nicely at the middle. No, yes on that one. And again, from the leftmost point, we go up 1, 2. Because it's up, I went +2. Your run from there is a 1. Anything divided by 1 is itself, which is 2. So up 2, which is a +2, over 1 would be your rate of change. In my experience, students have an issue with keeping their place in the count. Because of this, I'm showing a second method. Again, if the first method looks like it works for you, stick with it. It's less work and it's less confusing as this one. But for those people who can't seem to keep their memory or their place on where the count is, what you can also do with the same types of questions, and I think these are the same problems again, is count boxes. Now, we're not going to actually set these up to do like we did before, but I'll show you what they would look like. Again, you still find your 2 points. That's a good point there. That is a good point there. What you would do next is make a rectangle that connects these 2 dots, and that would be a rectangle. Notice that there's only 1 box going up, and there's 1, 2, 3, 4 boxes going over. And when you look back at the problem, if I can get it because I threw it out to the side, you still get the same answer, which is still 1/4. Alright? Looking at this one, again, good point here, good point here. Making a rectangle to connect those two, you draw a line that kind of goes like this. And again, notice there is 1 box going down, or 1 box overall, but it's going down, which makes -1. And there are 2 boxes going over, which makes your slope -1/2. Notice again how the slope was -1/2, even with the lines. Same thing here, good dot here, good dot here. Once you have the 2 dots, make a rectangle that catches both of those 2 dots. Notice this time my rectangle goes 1, 2, 3 boxes down, which is a -3. There's only 1 box going across, which is your 1. And again, remember, we did this problem already. There's your -3 there, your -3 there. And then in this one, there are your 2 good points. Make a rectangle that catches those 2 good points, noticing that we have 2 boxes going in an upward direction, 1 box going across, which is your 2 and your 2. Okay? No matter which method you use, you will have to practice so that it becomes more natural for you. You have to pick one. There really is no other way to do it. The first way that I showed should be the way you do it, but if that is too difficult, then just go ahead and make the boxes and try to do that. Please keep from writing inside of books. That way the students who are coming in behind you don't have you writing the answer for them. But if you get an option, use the boxes. But like I said, the best way to do it is just to kind of count the jumps using that rise over run. And again, as long as you remember that rise over run, your experience should take over from there. So good luck. I hope that helped. Remember to ask questions and practice in order to get better at this stuff.